Now test of identification. Identification of carbonylated compounds, aldehydes and ketones from other organic compounds. There are two tests that permit to identify if an organic compound has a carbonyl group or not, aldehyde or ketone, or another organic compound, alcohol, carboxylic acid, ester, and so on. We have two tests. First test with DNPH solution and second test with sodium bisulfite solution. First test with 2,4-dinitrophenylhydrazine DNPH. Procedure. In a test tube containing 3 ml of an orange DNPH solution of concentration 2 mol per liter, we add 2-3 drops of the organic compound, which is colorless liquid. We shake and observe. What are the observations? We have two possible observations. First, formation of yellow-orange precipitate, which is called positive test. This is the yellow-orange precipitate. We can say yellow precipitate, we can say orange precipitate, or yellow-orange precipitate. The second observation, we observe nothing, no precipitate is observed, the test is negative, the solution of the DNPH remains orange. Interpretation, what can we conclude from each observation? If the test is positive, that means formation of yellow-orange precipitate, then the organic compound has a carbonyl group, carbonylated compound, then it could be an aldehyde or ketone. But if the test is negative, no precipitate is formed, then the organic compound does not contain carbonyl group, then the organic compound is not aldehyde or ketone. This video shows this experiment. This is the colorless liquid organic compound. This is the color of the DNPH. It is orange color, not like this solution. This is the correct color, orange color. We add 2-3 drops. We observe the formation of yellow-orange precipitate. After 5 minutes, we observe the formation of yellow-orange precipitate. This is the yellow-orange precipitate that indicates that the organic compound is a carbonylated compound, aldehyde or ketone. Now, the other test is with sodium bisulfite, NaHSO3. Procedure: place in a test tube 3 ml of a colorless sodium hydrogen sulfite or sodium bisulfite NaHSO3 solution of concentration 2 mole per liter. Add 1 milliliter of the liquid colorless organic compound. Shake and observe. Observation. We have two possible observations. Formation of a white precipitate or crystals. Positive test. These are the white crystals. Or the other observation, no white precipitate is observed. Negative test. The solution remains colorless. Interpretation. If the test is positive, formation of white precipitate, then the organic compound has a carbonyl group, aldehyde or ketone. If the test is negative, no precipitate is formed, then the organic compound is not aldehyde nor ketone. This video shows this test. Bisulfite, not bisulfate. Bisulfite. Organic compound colorless and bisulfite solution colorless. We observe white color. This means we have formation of white precipitate. After 15 to 20 minutes, these are the white crystals formed. This precipitation indicates that the organic compound is carbonylated aldehyde or ketone. Okay, we identified the compound. We deduced that it is carbonylated aldehyde or ketone. How can we distinguish if the organic compound is aldehyde or ketone? We should realize more another test to identify whether this compound is aldehyde or ketone. A test with the DNPH or with NaHCO3 permits to identify whether we have carbonated compound or not, but they do not permit to identify whether this carbonyl compound is aldehyde or ketone. We should realize more tests. Okay, what are these tests? We have three tests. Test with Tollen reagent, test with Fehling reagent, and test with Schiff reagent. First, test with ammonical silver nitrate solution, which is called Tollen's reagent. Procedure: place in test tube 3 ml of a colorless ammonical silver nitrate solution, Tollen's reagent. Then add 1 ml of the liquid colorless organic compound, which is aldehyde or ketone. Shake, then heat the tube in water bath at 50 degrees. Observations: two possible observations. Formation of silver mirror in the bottom of the tube and the solution becomes black. This is the positive test. This is the silver mirror. Another observation: no precipitate is observed or no silver mirror is observed. Negative test. The solution remains colorless. Interpretation: if the test is positive, formation of silver mirror, then the organic compound is an aldehyde. If the test is negative, no silver mirror is formed, then the organic compound is ketone. Okay. Uh, Tollen reagent and the Fehling reagent uh, are two oxidation reactions but in basic medium. The oxidant in case of Tollen reagent is the silver ion Ag+. Aldehyde may undergo oxidation, then the test with Tollen reagent is positive. In this case, the Ag plus ions are transformed into Ag atom that deposit on the inner side of the tube, forming the silver mirror. In case of ketones do not undergo mild oxidation, then ketone does not react with Ag plus and no silver mirror is formed. This video shows this experiment. This is the silver mirror observed. Preparation of Tollen reagent is not needed, is outside of our curriculum. This is the negative test. Okay. We don't need preparation of Tollen reagent. This is the Tollen reagent, freshly prepared. We add the colorless liquid organic compound. Without heating, we cannot observe the formation of silver mirror. We heat for 5 minutes. After 5 minutes, we observe the formation of silver mirror, indicating that the organic compound is aldehyde. If in case of ketone, negative result obtained, we have no formation of silver mirror. The solution remains colorless. Okay, this is the Tollen reagent. Now, second test is with Fehling reagent. Procedures: place in test tube containing 3 ml of blue Fehling reagent solution. Fehling reagent is blue due to the presence of CO2 plus ions. Add 1 ml of the liquid colorless organic compound. Shake, then gently heat the tube in the flame of the Bunsen burner. The oxidant in case of Fehling reagent is CO2 plus. CO2 plus is the oxidizing agent. It is transformed into Cu plus. It is reduced into CO2 plus, into Cu plus. Cu plus of brick red precipitate, brick red color, sorry. Then CO2 plus is transformed to Cu2O, which is brick red precipitate, which is observed in case of aldehyde. Observations: we have two observations. The blue color of solution gradually changes into brick red precipitate, into brick red color, and a brick red precipitate is formed, which is the positive test. Other observation: no brick red precipitate is formed and solution remains blue, negative test. This is in case of ketone, the solution remains blue. In case of aldehyde, the solution becomes brick red color. After depositing for 5 minutes, we observe the formation of brick red precipitate. Interpretation: if the test is positive, formation of brick red precipitate, then the organic compound is an aldehyde. If the test is negative, no brick-red precipitate is formed, then the organic compound is ketone. Also, this video shows this experiment. This is the Fehling reagent, blue color. We add aldehyde to this tube and ketone to the other tube. We heat in warm water bath after certain time. Then aldehyde is transformed to acromance at the CO2 plus is transformed to CO2O, blue into brick red. This in case of aldehyde, brick red color. In case of ketone remains blue. After a while we observe the brick red precipitate. Test with Schiff reagent. Procedure: place in a test tube 3 ml of the colorless Schiff reagent solution. Cool the content of the tube in an ice water bath for 2-3 minutes. Then add a drop of the liquid colorless organic compound, then shake. Observations: 2 possible observations. If the solution becomes pink, positive test, or like this color, or the solution remains colorless, negative test. Interpretation: if the test is positive, appearance of pink color, then the organic compound is an aldehyde. If the test is negative, no pink color appears, or the solution remains colorless, then the organic compound is ketone. This video shows this test. This is the colorless organic compound. We observe the appearance of pink color, indicating that the organic compound is an aldehyde. Okay, these are the tests to identify if we have an aldehyde or ketone. Remark: there are other tests that permit to distinguish aldehyde from ketones. Theoretical test: if we realize the catalytic hydrogenation of the carbonylated compound, we have 2 possible products. If we obtain primary alcohol, then the carbonated compound is an aldehyde. If we obtain a secondary alcohol, then the carbonyl compound is a ketone. Or we realize the mild oxidation of the carbonated compound. If we obtain a carboxylic acid, then the carbonyl compound is an aldehyde. If we obtain a nothing, no mild oxidation, then the carbonyl compound is ketone. This is the end of chapter 9, aldehyde and ketone.